questions I can answer for you on these to make sure you feel comfortable with them. All right, so problem number 1 says we're given us the graph of f at x, and we want to complete this chart based on it. So what I'm going to do is I'm going to draw the graph, which looks kind of like this. So this looks like it's happening at 1. This looks like it's happening at -3. Okay, and then I think this is happening at -4. Okay, so that's basically all the information. So the reason why I copied it on the right side is right below it. I'm going to draw our f prime chart. Okay, so important information, you want critical values first. So the -3 is important, and the 1 is important. Okay, that is where the slope is 0. So slope is 0 at both. Go away. Go away. Good. It's at both -3 and at 1. Does that make sense? Because the tangent line here would be like this. The tangent line here would be like this. That's where I'm getting 0. 0 for slope for that linear equation. All right. So when we look at it, what does the slope here to be here? Positive or negative? What do you think? Positive, yeah. What does the slope appear to be here? Negative. And what does the slope appear to be here? Back to positive. Okay. So this is not necessary, but you know between a positive to a negative would be what they call a max. Between a negative and a positive would be what they call a min. Okay. A max is where it peaks and then comes back down. A min is where it hits the very lowest and comes back up, or a local. So they're called local maxes and mins, which means it's not the overall. Okay. So that's problem number 1. That's done. Pretty simple. Any questions I can help you with there? Okay, move on. Problem number 3. So I'm going to draw our graph here. So we have 1, we have 5. Let's pretend I can draw a really good graph. That's supposed to be a real straight line. Much straighter than I had. All right, so we have a value here at 3. So our sine line is going to look like this. 3. So what does the slope appear to be on this side? Positive. And the slope on this side appears to be negative. The slope exactly at 3 is a horizontal line, so the slope is what? 0. Okay? Seem okay so far? All right. Number 5 is where things start getting a little sketchy. And I'm walking around, I saw a lot of you are like, I didn't know how to do number 5. I get it. So let's do this. Give the intervals where it's increasing or decreasing. So we're looking for where this is increasing or decreasing. Okay. So they gave us the derivative here. Now, friends, if the derivative is set equal to 0, the derivative is finding the equation that allows you to do the instantaneous slope at a certain point. So if I set the derivative equal to 0, so I make this as 0, and I solve each of these, this will tell us where we start having turning points. Okay? So the turning point can be a point of inflection. It can be a max, a local max, or a local min. So I'm going to take each part of this and set it equal to 0. This is already factored for him. So I get this. So x is equal to what here? 0. And then I have this. If I square root both sides, I have a plus or minus 0. Plus or minus 0 is just 0. So then I get x equals 3. And then I'm going to take this last part, and I'm going to x plus 4 equals 0. Subtract 4 from both sides. So these three terms here, those are my critical values. Okay? That's where the slope is equal to 0. Make sense? All right. So if we create ourselves, give the interval. Okay, so I have to use a sign line. So I have -4 down here. I have 0 here. I have 3 here. So at all three of those locations is where the slope is 0. Yes, I do have to put them in left to right order. So from least number, most negative number to most positive number. So that's where I got those points from. Okay, so this region here. Okay, let's pick a value way to the left. Okay, so let's pick, say, -100. Is that way to the left from -4? And the reason I'm picking 100 is that's pretty easy to use. I could have used -10, it's still going to work. So think about this. If I plug it into this first part here, these all three of these are being multiplied together. Agree? Okay, so -2 times -100 is a positive number. And then I plug -100 in. -100 minus 3 is -103. If I take a negative number and I square it, I get a positive. And then if I take -100, plug it in here, I get -96. -96 is a negative number. So if I multiply a positive, and a negative together, I get a negative. So I have a negative here. Is that okay? So notice I'm not really worried about the values all too much. So then I'm going to pick, say, a point in here. I don't know. Let's pick -2. So I know I'm negative from -infinity up to -4. So then take -2, plug it in. Okay, so -2 times -2 is positive. And -2 minus 3 is -5. -5, a negative squared is? Hello. A negative squared is? Positive. And then if I take -2 and plug it in, -2 plus 4, does that give me a positive or negative answer? Okay, so positive times positive times positive is? Okay, so this region here is a positive region. Okay, so we can say that -4 is a local min because I went from negative, showing your way, negative to positive. So this would have been a min. All right, let's pick a number like 1. Okay, so take 1, plug it in. -2 times 1, positive or negative? 1 minus 3 is -2. Negative squared is? Positive. 1 plus 4 is positive. If I do a negative times a positive times a positive, I get a negative. A negative times a positive is a negative, times another positive is a negative, right? Okay, so I have negative, positive, negative as far as slopes. So this went from positive, so a slope like this, to a negative, a slope like this. So at 0, we are at a yeah.
So isn't it supposed to be you only have to figure one out and then figure the rest out? So then alternating instead of x minus 3.
Yes and no, because sometimes you can go negative, negative, which means you have a point of inflection, or it can go positive, positive, which means you.
Would that point be -3 or positive 3? That'd be not alternating.
Which one? Black, purple, or red?
It goes negative, positive, negative, negative. Because that 3 is, yeah, that's -2.
Okay, don't do the 3, do a value to the right of it, because the 3 is a slope of 0. Okay? So let's pick an orange. All right, so then let's pick something 3 to whatever. Thanks. Gotcha, thanks. So let's pick a value to the right of 3. So 10, 10's to the right. So negative 2 times positive, negative times positive is negative. 10 minus 3 is 7. 7 squared is a positive number. 10 plus 4 is a positive number. So negative times positive is a negative. What can you tell me about 3? It's the point of inflection. Okay? Now, friends, that's a very different thought process. Okay? You're utilizing a one-dimensional chart to base upon what the graph would look like. So if we were to graph, it doesn't ask to graph this, I don't believe. It doesn't ask us to graph it, but if we were to make a graph based on just this picture, if we have an XY axis, I have -4, I have 0, and I have 3. So our graph looks something like this. I have negative to here, and then it goes positive to here, and then it goes negative to here. We can keep going down if we need to. And then it still stays negative. So we have a negative slope here, a positive slope here, a negative slope here, and then negative slope here. Where because it goes from negative, the slope changes, but it doesn't change from positive to negative. So that's why that point of inflection takes place. So this could be like something like this, kind of rounded, like that. So that's basically what that graph could look like. Okay, I'm not saying that's exactly what it looks like, but if you were to graph that on a graphic calculator, I imagine you're going to get something similar. Whether or not it looks identical, it's still going to have the overall shape. Okay? All right, and then number 7. Number 7. All right, let's see how we do. Graph the following function, identify each of the following below. So I have f of x is equal to x squared minus 3x minus 4. So the first thing it asks for is the roots. Okay, so you could use Desmos on this, or you could realize, oh, I kind of sort of remember Algebra 1 where I'm going to get -4, x plus 1. Okay, that's what this would factor to. Okay, if you looked on Desmos, you would find that x equals 4, so 4 comma 0 is a root, and x equals -1, so -1 comma 0 is a root. So those are my roots. Okay, that's where it crosses the x-axis. Okay, if we were to create an f prime chart, interval where it's increasing, decreasing, interval, decreasing, max, min. Okay. So now we're going to try and figure out an f prime chart. I don't know why I'm saying chart. Okay, so far in the green, I know that I have this kind of situation. And the x squared is positive, so basically this is taking place. It's a parabola. Okay, that's what the original should look like. So we can create our f prime chart pretty easily off of this. Okay, it looks like we're going to have halfway between -4 and 1. Let's see, if I come in 1, come back 1, come in 1, come back 1, goes to here, like halfway in between that. So at like 1 1/2, or we could say that that is 3/2, or we could say it's 1.5. Any of those are totally fine. That's a turning point. Okay, that's a critical value without even doing the derivative. Okay, we could easily do the derivative of x squared minus 3x minus 4, and we could find it. So if I were just to find f prime at x, if I take the derivative of this, I'm going to get 2x minus 3. If I set the derivative equal to 0, I'm going to get this. If I use algebra 1 to solve that, where I add 3 to both sides, then I divide by 2, I get 3 over 2. Is 3 over 2 where we said the turning point's taking place? Yeah. So 3 over 2 is this value here. Or you could keep it as 1.5, or you could have it as 1.5. So looking at just our graph, being this is our turning point, meaning our slope is equal to 0 right here. On the left side of this graph, do we have a positive or negative slope as we come down this graph? Negative. And on the right side of this graph, do we have a positive or negative slope? Positive. And if it goes from a negative to a positive, does it form a min where my fingers are? Yeah, so this would be a minimum value, okay? So the intervals where it's increasing, my thing is getting slow for some reason. So it's increasing from 3/2 round bracket to infinity. Increasing means the slope is positive. Where it's decreasing, I'm putting decreasing. It's going to decrease from negative infinity to 3/2 round bracket. And this is where our slope would be negative. Okay? So this is our intervals for increasing, decreasing. We have max, min. We do have a min that we labeled. That's our min. We have our f prime chart. This is our f prime chart. Okay? And we have our roots. So Desmos should be your friend on this, because if you use Desmos, you could graph it. You don't have to know exactly what it looks like, but things you're looking for when it graphs is you're looking for the turning point, the max, the min, or the point of inflection. So this would look like a max. This would be a max. This would look like a min. A point of inflection, the graph would do something like this. It would have kind of like this little wave thing. So if you are using Desmos and you got something graphed, you want to figure out where these values are just by kind of moving over to it. I mean, we're not going to give you something that, happened at, some irrational decimal that goes on and on and on forever. We're going to give you like something that's going to happen. It's like, hey, it's looking like it's happening at about 1.5. Cool. Use 1.5. That looks like it's happened at 7.7. Cool. Use 7.7. Okay. So, and then the intervals where it's decreasing or increasing, that is something that you would see, but just be very cautious. Okay. So, some of you, just a reminder, some of you, as far as paper stuff goes, Ariel, Andrew, Lauren, Connor, Virginia, Perry, Stella, Jack, Caden, and Ariel Morales, there is a quiz that you owe me. Okay? If I go on to Schoology, so Gavin A, you owe me the limits quiz still. Dalton B, you owe me the limits quiz still. Ethan L, you owe me the limits quiz still. Evan M, you owe me the algebra review and the limits quiz. They're both on Schoology. Caden M, you owe me the limits quiz on Schoology. Ariel Morales, you owe me the limits quiz on Schoology. Andrew P, you owe me the limits quiz on Schoology. Brady, you owe me the limits quiz on Schoology. Jackson S, you owe me the limits quiz on Schoology. So there are a lot of you that still owe me some stuff. I'm happy to take it for full points. Unfortunately, right now the stuff on Schoology is counting against you. I just gotta make sure what my terminology says on my grade book. If you owe me the derivatives quiz, which was pencil paper, 10 questions that you can use the stuff on. The derivatives quiz, if it's not made up by the end of tomorrow, so basically Thursday morning, before school is when I put in a 0 as a placeholder, which has a negative effect on your grade. Okay? So, let's play, don't take zeros as, oh, I can't make it up. 0 just is, hey, I give you about a week's worth of time, 5 to 7 days worth of time to make it up. It's not made up. In order to kind of inspire you to realize it's okay to make it up, I put a 0 in, which is not, your grade is not indicative of what you know if I put zeros in because something's not done. I'm happy to change grades. Okay, that's not a big deal to me. It's just, please make them up. If you're running into problems, come ask me. And the nice thing about anything on Schoology is if you start it, you can come back to it. It's resumable. Okay, so figure it out. Come see me if you need help. Monday, Wednesday, Friday before school I'm available. I'm also available periods 4, 6, or 8, either in here or in the office right next door, depending on where I'm at. After school, if you let me know you're coming, so make sure I'm available, because I sometimes have to, like this coming Friday, I have to get over to the gym right away to get set up for basketball. But so just I'm not trying to punish anybody. I'm just trying to give you a heads up, saying, hey, this is what's going on. Okay. So your assignment for tomorrow is still worksheet 5.1. Finish all of it. Okay, we did the odds, so that just leaves you the evens. Good enough? Save.